next question is find the coordinates of the point of intersection of the tangents at the points where x plus 4y minus 14 equals to 0 meets the circle x square plus y square minus 2x plus 3y minus 5 equals to 0. The question is circle s is equals to 0 is there, and the coordinates of the point of intersection of the tangents at the points where this line is there, x plus 4y minus 14 equals to 0. This line is there. This line touches the circle at these points. So now through these point of contacts A and B, through these points of contacts A and B, one tangent is drawn and another tangent is drawn. Let us suppose that these two tangents joined at P. So what is this P? This P is the point of intersection of the tangents, at the points where the line meets the circle, that is the point of contacts, through point of contacts. So this is the tangent drawn through the point of contact A, and this is the tangent drawn through the point of contact B. So the point of intersection of these tangents meets at P. So this point of intersection of the tangents, so we have to find. Solution: let Px1 comma y1 be the point of intersection of tangents. So the polar of Px1 y1, the polar of Px1 y1 with respect to the circle s equals to 0 is s1 equals to 0. So what is s1 equals to 0? For this s equals to 0, s1 implies xx1 plus yy1 minus of x plus x1. So minus remains the same. So coefficient of x is half. So 1 into x plus x1 plus the coefficient of y is 3, half of that. So 3 by 2 into y plus y1 minus 5 is equals to 0. So let us take an LCM. So 2xx1 plus 2y1 minus 2x minus 2x1 plus 3y plus 3y1 minus 2 5s are 10 divided by 2 is equals to 0. So this 2, when we multiply with a 0, 2 into 0 is 0. Now, so here 2x x1 minus 2x, take 2x in common, then x1 minus 1 we are getting. So in these two, 2y y1 plus 3y, take y in common, then I am left with 2y1 plus 3. So 2y y1 3y, take y in common, then 2y1, take y in common plus 3. So minus 2x1 plus 3y1 minus 10 is equals to 0. See, what I am doing is, this is the polar equation, and polar equation is a straight line, and straight line is of the form, the general form of the straight line is ax plus by plus c equals to 0. So first degree equation I am converting into. So x, y and constant, that's it. That's what my intention is. So this is equals to 2x into x1 minus 1 plus y into 2y1 plus 3 minus of, take minus in common, 2x1 minus 3y1 plus 10 equals to 0. So next, given line is what is this given line? Given line is AB, or in other words, what is AB? Chord of contact. Remember, what is chord of contact? The line joining the points of contacts is called the chord of contact. So the chord of contact is x plus 4y minus 14 equals to 0. So if the point P lies outside the circle, this chord of contact, the polar is the chord of contact. So what I mean to say is the line AB is the chord of contact, I said right now. Otherwise it is a polar also. If a point P lies outside the circle, the chord of contact is the polar. If P lies outside the circle, polar cuts the circle in two distinct points. So this chord of contact will be equals to polar. So this is a second equation, I suppose. This is the first equation. So both the polar of P with respect to circle is this line, and the same line is the polar, which is given to be x plus 4y minus 14 equals to 0. So 1 and 2 represents same lines, represents same straight lines. So let us compare the equations. That is equals to, that implies the coefficient of x here is 2 into x1 minus 1 by 1 is equals to, the coefficient of y is 2y1 plus 3 by 4 is equals to minus of, this is all constant. So 2x1 minus 3y1 plus 10 by minus 14. So minus minus gets cancelled. So first and last you compare, then we will be getting one equation in terms of x1, y1 and constant equals to 0. Similarly, second and last if you compare, then again x1, y1 constant, so is equals to 0 we are getting. So we are getting two simultaneous equations. Then if you solve these two simultaneous equations, which is containing which is in x1, y1, then we will be getting the point of intersection P x1, y1. So for this, so 2 into x1 minus 1 by 1 is equals to 2x1 minus 3y1 plus 10 by 14. So you just cross multiply. 14 2s are 28 into x1, 28x1 minus 14 2s 28 into minus 1 minus 28 is equals to 2x1 minus 3y1 plus 10. That implies 28x1 minus 2x1 is 26x1 minus 3y1 if you take to this side plus 3y1. Next, minus 28 minus 10 minus 38 is equals to 0. Let us suppose this to be the first equation. Similarly, this and this if you compare, then 2 2s are 4, 2 7s are 14. So cross multiply, 7 2s are 14y1 plus 7 3s are 21. So 2 into 2x1 is 4x1 minus 2 3s are 6y1 plus 2 10s are 20. So this is 4x1 minus 6y1 minus 40y1, 14y1 minus 20y1. This is 20 minus 21. So minus 1 equals to 0. So let us suppose this is fourth equation. So for this is one straight line and this is one straight line. These two tangents we are getting. So solving these two, we will be getting P. So solving these two, we will be getting x1, y1. What is this x1, y1? This is P. That is what we are required to find. So solving 3 and 4. 26x1 plus 3y1 minus 38 equals to 0. 4x1 minus 20y1 minus 1 equals to 0. So solving we get, so x1 by y1 1 by, this method you know, this is cross multiplication method. So x1 into 3 into minus 1, so minus 3 minus minus into minus plus into minus minus 38 2s 76, so 76 760 y1 by, so y1 by 38 41s 38 14s, so y1 by 38 14s 152, so minus 152 minus 26 into minus 1, so plus 26 1 by, so 26 20 is minus 520, 26 into minus 20 is minus 520 minus 4 3s are 12 minus 532. Therefore x1 comma y1, x1 is equals to minus 763 by minus 532, y1 is equals to minus 126 by minus 532. So gets cancelled here, this is, so therefore p x1 comma y1 is, so 7 table if you cancel 7 into 109 by, so 7 sevens are 49, so we are left with 476 comma 14, and this is 9 by 38, so 14 nines 14 38s. So this is the point of intersection px1 y1 of the two tangents. The next question is, find the locus of the point with respect to the circles. This circle and this circle are mutually perpendicular. Locus of the point. The next question is, find the locus of the point whose polars with respect to the circles are mutually perpendicular. So let px1 comma y1 be the locus. Okay, be the locus. So the equation of polar of P with respect to circle x square plus y square minus 4x minus 4y minus 8 equals to 0 is s1 equals to 0. That means x1 plus y1 minus 2 into x plus x1 minus 2 into y plus y1 minus 8 equals to 0. So from this, x1 minus 2x, if you take x as a common, x1 minus 2, y1 minus 2y, take y in common, then y1 minus 2. So minus 2x1 minus 2x1 minus 2y1 minus 8, so is equals to 0. Let the slope of this be m1, and what is m1? Minus a by b minus the quotient of x, x1 minus 2 by y1 minus 2. Likewise, equation of polar of P with respect to, this time another circle is x square plus y square minus 2x plus 6y minus 2 equals to 0 is s1 equals to 0. So x1 plus y1 minus of x plus x1 plus 3 into y plus y1 minus 2 equals to 0. So xx1 minus x, take x in common, x1 minus 1 plus y1 plus 3y, take y in common, y1 plus 3 minus x1 plus 3y1 minus 2 equals to 0. Let the slope of this be m2. So what is m2? Minus of x1 minus 1 by y1 plus 3. So given that the lines are perpendicular, that means m1 m2 equals to minus 1. m1 is minus of x1 minus 2 by y1 minus 2 into minus of x1 minus 1 by y1 plus 3 is equals to minus 1. Minus gets cancelled. That is equals to minus of x1 minus 1 into x1 minus 2 is equals to y1 minus 2 into y1 plus 3, cross multiplication. So from this, if you take all this onto RHS, x1 minus 1 into x1 minus 2 plus y1 minus 2 into y1 plus 3 equals to 0. So this implies x1 into x1 square minus x1 minus 2x1, so minus 3x1 minus into minus plus 1 to the 2 plus y1 square y1 into 3 3y1 minus 2y1 plus y1 minus 2 3 is a 6 equals to 0. So therefore the locus. So the next question is, find the locus of the foot of the perpendicular drawn from the origin. So let us suppose that this is the origin O. So origin to the chord of the circle. So let us suppose that this is the circle. This is the circle. So this is a chord. So this is the center of the circle, for example. So then if you join this line from the origin to this chord, then this is the foot of the perpendicular. Let us suppose that this is P. What is P? P is the foot of the perpendicular drawn from origin to this chord. So if I join this, so let us suppose that AB is the chord. So this OA and OB, pair of lines passing through the origin. So these are 90 degrees is given. Perpendicular is given na, subtends at right angle at the origin. So we need to find out the locus of P. So solution, let the locus of P be Px1 comma y1. So the slope of OP is So this is 0, 0 and this is x1 comma y1. So y1 minus 0 by x1 minus 0. y1 minus 0 by x1 minus 0. The slope of the line joining the 2 points x1 and x2 y2. So y2 minus y1 by x2 minus x1. Difference of the ordinates by difference of the abscissa. So this is equals to how much? y1 by x1. Then what is the slope of AB? This is equals to minus x1 by 1. How can you say? Since OP is perpendicular to AB. Since the lines are perpendicular, the product of their slopes is minus 1. So y1 by x1 into minus x1 by y1. So y1 by 1, x1, x1 gets cancelled. We are left with a minus 1. Okay. Therefore, the equation of the line. So we have a line AB is, equation of the line AB is, so for this line we have the slope, just now we have found, and it is passing through x1 y1. So we have a point and a slope. We have slope point form, right? Is y minus y1 is equals to m into x minus x1. That is y minus y1 is equals to m is equals to minus x1 by y1 into x minus x1. So cross multiplication y into y1 by y1 minus y1 into y1 is y1 square is equals to minus xx1 minus into minus plus x1 square. This implies x1 square plus y1 square is equals to x1 square plus y1 square equals to xx1 plus y1. This implies xx1 plus y1 by x1 square plus y1 square is equals to 1. So this one we got. Now in first year we have done this question. See this. So this is the curve. Second degree non-homogeneous equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. Second degree non-homogeneous equation s is equals to 0. And so OA is a line and OB is a line. So OA and OB intersects the circle S is equals to 0 at 2 points. Then I just join AB. Now, so what is OA and OB? OA and OB are the pair of straight lines passing through the origin. So what did we do? Homogenizing the circle equation, homogenizing the second degree non-homogeneous equation with respect to the line AB. So that's what we have done. So now, since this is a second degree non-homogeneous equation, so what is a non-homogeneous equation? So here x has the power 2, y has the power 2, 2gx, x has the power 1, y has the power 1. See, we neither had x nor y. So its power can be assumed as 0, for example. Then here 2, 1, 0. So it is the mixed combination of all the powers. Therefore, we need to homogenize this. How? X square plus y square plus 2gx into 1 plus 2fy into 1. Why 1? Because its power has to be raised to 1. And C, since it is a 0, its power has to raise to 2. So 1 square I can write. So what is 1? This one we are going to utilize it. This one has to be utilized. So since OA and OB are perpendicular to each other, so 90 degrees, then whatever the answer we are going to get here, coefficient of x square plus coefficient of b square equals to 0. Because what is cos theta? If theta is the angle between the pair of lines, then cos theta is modulus of a plus b by square root of a minus b whole square plus 4h square. Since theta is perpendicular, okay, since the lines are perpendicular, theta is to be substituted 90 degrees. Cos 90 is 0 is equals to a plus b by square root of a minus b whole square plus 4h square. Theta is 90 degrees. Cos 90 is how much? 0, yes. So cross multiply. So 0 into this is 0. So a plus b equals to 0. What is a? This is ax square plus 2hx square plus by square equals to 0 is the second degree homogeneous equation. So coefficient of, what is a plus b? Coefficient of x square plus coefficient of y square equals to 0. So that's what we are going to do for this problem as well. So to obtain the final locus of P. The combined equation of OA and OB is homogenizing S x square plus y square plus 2gx plus 2fy plus c equals to 0, homogenizing the second degree non-homogeneous equation with respect to the line AB is, so this is line, this is the line, okay, so implies x has a power 2, therefore we are not going to do anything for this, so y square plus 2gx and x's power is 1, so its power is to be raised for 1 plus 2fy, its power is 1 again, so its power is to be raised to 1. Why? Because this is the second degree non-homogeneous equation, everywhere power 2 is to be maintained, plus c, it is neither x nor y, so its power is to be raised to 2 is equals to 0. And what is this one? This one we have prepared already. So implies x square plus y square plus 2gx into what is 1? xx1 plus yy1 by x1 square plus y1 square plus 2fy into xx1 plus yy1 by x1 square plus y1 square plus c into xx1 plus yy1 by x1 square plus y1 square whole square equals to 0. So this can be x square plus y square plus, for this 2gx and 2fy, so this is common, so 2gx plus 2fy into xx1 plus yy1 by x1 square plus y1 square plus c into xx1 plus yy1 by x1 square plus y1 square whole square equals to 0. This implies x1 square plus y1 square whole square is the LCM. So x square plus y square into x1 square plus y1 square whole square plus 2gx plus 2fy into xx1 plus yy1 into x1 square plus y1 square plus c into xx1 plus yy1 whole square equals to 0. I have taken x1 square plus y1 square whole square as an LCM. Then x square. So since OA is perpendicular to OB, coefficient of x square plus coefficient of y square should be equals to 0. What is the quotient of x square here? Quotient of x square is this, x1 square plus y1 square whole square, x square into this. So what is the first? Let us write a quotient of x square first, plus here 2gx into x, 2gx square into x1 into this. Okay, because 2gx into xx1, 2g x into x square. So 2g x square x1 into this. I'm telling you 2g x into x. So 2g x into x square x1, and this and this I just multiplied. This is multiplied with x1 square plus y1 square, right? Now what is the quotient of x square? So 2g x1 into x1 square plus y1 square. So, and plus here, if you expand this c into a plus b whole square, a square plus b square plus 2ab. A square is x square x1 square plus y square y1 square plus 2 xy x1 y1, right ma? So here if you multiply c into x square x1 square, so the quotient of x square is cx1 square, and we don't require any terms from here on because c into 2xy, so xy term we are getting. So this is all the coefficient of x square plus similarly what is quotient of y square? Simply from this we can do y square into this. So y square quotient is x1 square plus y1 square whole square plus here 2fy into y1. If you multiply y into y square, 2f y1 into this. So 2f y1 into x1 square plus y1 square plus here if you expand this, so x square x1 square, y square y1 square, a square plus b square, 2ab term you leave, and x square already we have taken. So here c y square y1 square, c y square quotient is c y1 square. So c y1 square. So this is all quotient of x square, and this is all quotient of y square equals to 0. Why this a plus b equals to 0 we are doing? Because ax square, see, since so this is a straight curve and we are homogenizing this. So this is a b. OA and OB are the combined equation of the pair of lines passing through the origin. So ax square plus 2hxy plus by square equals to 0 is the second degree homogeneous equation. And what is the angle between the second degree homogeneous equation? Cos theta is a plus b by square root of a minus b whole square plus 4h square. Theta is 90 degrees if I substitute. Cos 90 is a plus b by square root of a minus b whole square plus 4h square. Cos 90 is 0 into denominator 0 something. So a plus b equals to 0 is what we are getting. So already I have explained before this. Okay, so we are just one step lesser to meet the final answer. So this is what I got. Now x1 square plus y1 square whole square plus x1 square plus y1 square whole square is 2 into x1 square plus y1 square whole square plus 2gx1 into x1 square plus y1 square 2fy1 into x1 square plus y1 square. So 2gx1 plus 2fy1 into x1 square plus y1 square. Nothing. And I have just taken x1 square plus y1 square common in both of these terms. So x1 square plus y1 square I have taken common. I am left with 2gx1 plus 2fy1 plus cx1 square plus cy1 square. Take c in common. Then x1 square plus y1 square is equals to 0 I got. Now can I take x1 square plus y1 square as a common throughout this equation? Take x1 square plus y1 square common. Then I am left with 2 into x1 square plus y1 square. This is a square. A I have taken common. Another a I am left with plus 2gx1 plus 2fy1. Since x1 square plus y1 square has taken common, I am just left with the 2gx1 plus 2fy1 only plus x1 square plus y1 square is taken common plus c I am left with is equals to 0. So this is getting multiplied. So it would be if you transpose this onto the other side, 0 by x1 square plus y1 square is 0. So what I am left with is 2 into x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equals to 0. So therefore the locus of since px1 y1 has taken as the locus point, so its behavior in the plane is, therefore the locus of px1 comma y1 is, so you have to generalize this answer. So wherever you find x1 y1, you simply take x1 y1 off. Then 2 into x square plus y square plus 2gx plus 2fy plus c equals to 0 is the locus of P.